Dear colleagues, I would like to discuss some very interesting aspects that related to general explanation of general properties of LENR. General independent from the kind of material, for example, gas, solids, crystals, biology system, low energy plasma, so on. Among well-known LENR paradoxes, three ones are most important, of course. First of all, it is absolutely inexplicable from the point of standard nuclear physics, anomalous large, in fact, giant probability of Coulomb barrier for light, for both light, for middle mass, and heavy charged particles. Also, next one, very essential change of ratio of channel probability. In fact, total suppression of radioactive channels that lead to the creation of radioactive daughter isotopes. Total suppression. It is very strange because in usual nuclear physics, the probability of channels that lead to stable and unstable isotopes approximately the same. And also very sharp suppression of intensity of gamma radiation by many order of magnitude. Typically, in all theoretical models, discuss only first problem, very giant increasing intensity of transparency. But according to our models, our discussion, all three properties is very connected. In fact, it is a result of reflection of one physical phenomenon. Okay. Let's very simply the traditional point on the tunneling probability, for example. It using the gamma formulas, such gamma formulas, yes. It easily calculate the probability of such transparency of potential barrier, and for example, at typical temperature for low energy reaction from room temperature up to maybe 1,000 degrees, the coefficient of transparency, it is very low. It's very low for both light and more heavy isotopes. Also, some positive influence is if we take in attention the process of screening, potential screening that's connected with electronic shell, of course. It is well-known results, of course, it's possible if you have introduction the screening energy. For different isotopes will be different screening energy. For example, it may be several tens for very light or several hundreds more heavy isotopes. But in any case, the coefficient of probability is very low. Very low. It is very far from condition of real experiments. The traditional approach to the physics of charged particle tunneling is based on assumption of mutual independence of the particle states corresponding to each energy level in quantized system. For such systems, the tunneling probability for each state is also mutually independent. This is very inefficient system. The conceptual base of the tunneling effect is connected with wave-particle duality, is well-known standard Heisenberg uncertainty relation. There are different kinds of such relations. For example, relation for energy of pulse and energy, or pulse and coordinate, or energy at time, so on. Such expression were created in 1927, and generalization was made in 1928 by Robertson by introduction of some operator of different physical value. For example, such it is the product of dispersion. It's the A, B. It is the operator of different expression. For example, if pulse and coordinate are the same, and so on. Okay. Such relation, Heisenberg or Schrödinger-Heisenberg relation, may be introduced for explanation for such simple estimation of the tunneling probability. Very simple way, also well known. We can, for example, introduce the quantum mechanical uncertainty skin layer based the mean square effective radial momentum of particles, and also using such equation, we can change it or transform such expression gamma of probability, such view. In fact, is the exponent power relation of size of potential barrier to the quantum mechanical skin layer, such value. If in the case of low energy, such condition takes place, if we have, of course, the same results. It is different point of view, but it's the same problems. Okay. A very interesting moment was created in 1930 by Schrödinger and Robertson, not Heisenberg and Robertson, but Schrödinger and Robertson, independently generalized the Heisenberg idea of quantum mechanical uncertainty of different dynamical quantities A and B for the case of mutual coherency of the particle states. And they received the modified such modified ratio, this one modified ratio. What is different between initial and Robertson? It's present or coefficient of correlation. This coefficient correlation, and it is a ratio of cross dispersion, such cross dispersion of that taking attention statistical or quantum mechanical connection between dynamical variable. And for example, if we have the same traditional units, for example, pulse and coordinate, we have the modified equation relation, certainly relation, different, it's present such value. Coefficient of correlation is maybe very, very close to units. And of course, in this case, the right side of such a relation will be very great. For this difference may be taken attention if you introduce the effective Planck constant. It is very important relation because Planck constant, in fact, it is a value that is shows the border between quantum mechanical description of what and classical description of what. If the Planck constant is very sharply increases, so we have distributed, or we have introduction quantum mechanical idea on the macroscopic system. Okay, if we using such modified uncertainty relation, in the same gamma formulas, for example, we have a very interesting result. So coefficient of transparency for correlated state, where coefficient correlated is not zero, is the coefficient for equal to 0 powered by such square root. Such square root is very close to 0. So in this case, very interesting. At any low energy, the transparency of barrier will be close to 100% if we have very correlated state. Very interesting idea, general idea. What is the simple estimation of such effect? Let's consider the particles that are situated in the potential hole. For example, we have many level system. It is a ratio, it is a uncertainty modified uncertainty relation. And easy using the fluctuation of pulse of such relation, it easy calculates the fluctuation of kinetic energy here is calculation. And some simple estimation. If you have uncorrelated state, so fluctuation of energy in potential hole with size about 1 angstrom is very, very small. And if you have the coefficient correlation is close to units, or there is introduced not coefficient correlation, but coefficient of efficiency correlation. In fact, such value it is equal 1 to square root such. Such a coefficient equal about several thousand. Fluctuation of energy will be several tens up to several hundreds keV. And of course, in this case, it very sharply increases the transparency of potential barrier. On this picture, you can see very simple model, very simple estimation. What is the physical reason of such phenomena? It's very simple calculation. If there's a fluctuation, total in uncorrelated state, we have in the state of coherent superposition, non-coherent superposition. So particle may be on different states with different probability, and if the phase is absent of phasing between such state, in any time the fluctuation of pulse is very small. But if we have the correlated cophasing state, we have the constructive interference. And in some moment time, that periodical moment time, we have the creation very large giant fluctuation of energy. And also it is very interesting. average fluctuation of time for non-correlated state is proportional to the number of levels, and in correlated to proportional number power 2 of level. Because number of level is very large, maybe several thousand, it leads to very increasing amplitude of correlation. Okay, of course. How create such correlated states? There is a different method. We have studied this problem during the last 50 or 20 years. And for example, very simple model. If you have particles that are situated in potential well, in the state of there is many level of quantization, and if you have, for example, such modification of parameters of potential hole, in this case, increasing of size, for example, increasing, or the same physical model, we have some cracks and increasing of size of cracks. During the process of increasing of such potential hole, the process of cophasing takes place, and it leads to formation of coherent correlated states. For example, this very simple estimation. If we have increasing potential hole, or well, from size of cracks, if we have increasing the size of potential from 2 angstrom up to 2000 angstrom, the initial, in uncorrelated state, the coefficient of transparency for DD reaction was 10 power minus 19, if you intention the screening intention. And in correlated state, coefficient of transparency is 0.85%. Or the same situation, nickel plus phosphor plus proton is also increasing up to 10%. If we have the much large increasing size of potential well, for example, from 2 angstrom up to 1000 angstrom, this one, or to 2 microns, from 2 angstrom to 2 microns, coefficient of correlation will be very close to units, and we have the same coefficient transparency 98%, fantastic value. Okay, the same effect takes place not only during the growth or increasing of size of potential well, but also decreasing. For example, the same result and the same calculation. It is very interesting, such phenomena take place in different physical systems. For example, in well-known Lugano experiment, you can see the photo of foil before experiment and after. You can have many number of cracks. Each cracks, it is a place where the process of, according to our understanding, process of formation of correlated state take place. And also the same phenomena take place not only in solids, for example, in liquid, in biology system, because in biology system, the same process of formation and deformation, non-stationary, dynamic or nanowhole takes place. For example, during the process of cell division, we have one cell and also process division. In the space between two cells, in fact, it is a non-stationary potential hole with increasing of size. If in this area will be present several nuclei, such nuclei will be created coherent correlated states. It leads to nuclear reaction. And many different places, for example, division of DNA, processes on the membrane, and so on. Okay, it is a general. This question was related only to the very high increasing of the transparency of potential hole. But there are another condition. What condition? To realize the exoenergetic nuclear reaction, due to fluctuation energy, with necessary information about fluctuation of energy and duration of such fluctuation. It's a principal difference between standard nuclear physics, where we have particles with realistic energy that exists for a long time. In this case, we have large fluctuation energy that exists in very short time. So, there are three basic conditions necessary. First one, the fluctuation energy must be large enough to overcome the Coulomb barrier. It's related to my preview discussion. About 30-50 keV it is enough. But also, the total reaction time, including the two steps, duration of tunneling effect and duration of reaction that take place in compound nuclei, must be should be less the duration of the fluctuation. Because fluctuation energy, the process where have both fluctuation for short time. All process will be finished during such process. It is very not simple. And also the energy released during the reaction must exceed the borrowed fluctuation energy. Here is a scheme of such reaction in generally. It is a burst of fluctuation, time of transparency, formation of compound nuclei, finish of reaction, and returning energy. So the burst energy and destruction energy. It is very important part of this process. And also, from the very simple but not correct point of view, any large fluctuation energy may be using but uncorrelated state. If we have, for example, usual relation of Heisenberg and certain relation, of course, by such relation we have create any much giant fluctuation of energy. But if the fluctuation of energy is about the same 30-50 keV, duration of existence of such fluctuation is very small. It's not enough, it is very small value for realization of nuclear reaction, because by using uncertain relation, reaction is absolutely impossible. So it is very interesting. What main question? What is the duration of giant energy fluctuation in coherent correlated states? From the general point of, if we base on the equation that was created by Robertson and Schrödinger about 90 years ago, such value may be calculated using such equation. What? Such equation. Very good formula, okay. But for such calculation, we need now the operator of energy of operator Hamilton. It is normal, we well know, but also time operator. But unfortunately, all known form of time operator, if there are different forms, is incorrect because it is a non-Hermitian. It is not possible using such formula. In fact, we have a very beautiful general theory, but absolutely impossible using such formula for calculation what is the duration of giant fluctuation of energy. Up to last year, up to this year, this problem was solved. But this year, in the beginning of this year, we have published an article in Journal of Theoretical and Experimental Physics where we have solved this problem. Very briefly inform you about this. The fluctuation of the coordinate delta Q, is connected with duration of fluctuation by the obvious relation. Yes, of course. Duration of coordinate is, after such system equation, is less than maximal velocity of motion of particle during the conservation, and duration and duration and what it is, and duration conservation and divide by two because any fluctuation begin from point, we have the fluctuation coordinate and return trip. So we have two ways, to and return trip. So where max is the maximum velocity during this fluctuation. We have make the such simple estimation that maximal velocity or maximal kinetic energy of fluctuation is in several times more than average energy. Typically, this coefficient ends from 3 up to 5. So the average, if we can calculate it, fluctuation of energy it depends from the fluctuation of pulse and mass, and also the fluctuation of the coordinate may be calculated. Oh, it is the same. Sorry. So using this formula and the uncertainty relation, this one equation, it easy we find the final expression for estimation for duration of fluctuation in correlated states, but based not unknown parameters for correlation between energy and time operators, but operators pulse and coordinates that we can easily calculate. So we have such modified expression for estimation of time of fluctuation depend only on parameters that we can calculate related to pulsar coordinate. Such expression is very similar. It's very similar to the unknown, but very beautiful, but unknown parameters. You can see different. It is a correlation energy time, and this correlation pulse coordinate. So we have such very interesting estimation, and this was published here. And by this expression, it is calculate unknown process. Let's consider once more the same process. Okay. The same process, for example, interaction of lithium plus proton. Why lithium? Because there is well-known experiment in Lugano, very precision measured the changing of isotopic ratio for two main isotopes of lithium. So we have calculated, for example, first one, it is a duration of transparency. Duration, we have calculated duration of transparency, and for fluctuation of energy 30 keV, duration of transparency for such reactor is about 10 by 10 power minus 20 seconds, duration of first step. Next one. Let's consider two cases, correlated and uncorrelated state. Uncorrelated state, usual system. In uncorrelated state, for example, using such Heisenberg and Circular relation, for example, let's consider reaction Li-7 plus proton correlation beryllium-8 and final generation to alpha particles. If energy of fluctuation 30 keV, duration of uncorrelated fluctuation 10 power minus 20. But total duration reaction, including duration of transparency and decay of compound nuclei, is 4 by 10 power 30. We have not good relation. Duration less than such value. Let's consider different reaction. Li-7 plus proton, beryllium-7. The same situation. Duration fluctuation the same. Duration relation 10 power minus 30. You can very different. So, in any case for such isotope in os another, duration of fluctuation, so duration of existence of giant fluctuation energy is very small to the necessary limit that dependent from the total finish of cycle of reaction, transparency and decay. So as reactant possible, it's well known. Okay, let's consider correlated states. What is the difference? Let's consider correlated state. In this duration of correlation, according to our formula, typical, is 10 power minus 7, 18 second correlation. And duration of reaction, such. You can see the duration of fluctuation by 200 times more the duration of reaction. So in this case, absolutely possible simulated nuclear reaction by fluctuation. Let's consider another reaction, Li-6 plus proton. In this case, duration is the same, but duration reaction opposite condition. Much more the duration is reaction is impossible. So we have do now the experiment of Lipinski and Lipinski, where interaction of proton with lithium at low energy, and was observed only alpha particles with energy about 8 megavolt. Megavolt is two particles that create during decay of beryllium-8 at reaction Li-7, but totally absent any alpha particles in the area about 2 MeV. It is particles that created during reaction with presence of Li-6. The same result, of course, was shown in the experiment in Lugano. Initial ratio Li-6 9%, Li-7 92, final Li-6 92 and Li-6 7. So reaction participate only Li-7. Because why? Because for one channel it is possible stimulation, for another channel, another top is impossible because of different time relation, fluctuation and time. So is similar weight is easy show that why is it not created radioactive isotopes? Because in fact, after creation of compound nuclei, what is it radioactive isotopes? It is an isotope where duration of decay of compound nuclei is very large. But it is shown, if the duration is very large, it is absolutely impossible to simulate such reaction because duration of fluctuation will be much more the duration reaction, but one will be with less. And the problem of gamma rays, we well know that duration of gamma decay, in any case, for much shorter gamma transition, electrodipolar transition type of E1 or magnetic transition type of M1, in any case, duration of the gamma decay is more than 10 power 13, 10 power 15. But duration fluctuation is about 10 power 18. So, of course, it is very shortly suppressed such gamma channel of decay. It's why we have not observed a very strongly suppressed gamma radiation and very totally suppression of radioactive channels of nuclear decay. And only conclusion, in fact, conclusion is I have discussed it during my presentation. Thank you for attention.
So it seems there is some correlation with the old model of Professor Preparata. Do you think there is some link between your model and the old model of coherent states of matter, Professor Preparata?
Yeah. Maybe answer will be the following. There is a very large list of publications where different aspects of such model was published. About several tens articles, The last article is published was in 2019. It is very interesting. Such articles all was published is higher level physical journal. For example, PhysRem, European Physical Journal, Annals of Nuclear Energy, Journal of Experimental Physics. All this data.
Okay, moment. Maybe there is some misunderstanding in my bad English. My feeling is your model, very nice, for some aspect starts from the old model Professor Preparata about the coherent state of matter. Do you think my feeling is wrong or there is some correlation? Sorry.
Yes, I have now. I need to discuss. I need to discuss more detail because in general I don't know.
Okay, thank you.
I don't know what model are you talking.
To answer Francesco's question, this is an answer to Francesco's question. Yes, I do believe that there are correlations. The difference is the fact that what has been presented is a general overview, a general approach to this kind of correlations. And so there is no contradiction between the two approaches. So there is a correlation.
Contradiction to what?
There is no contradiction. No contradiction.
No. We have made the analysis of all successful experiments. All experiments is by the action of magnetic field, action of lighting, in the solids, in liquids, in gas, in biology systems, in different places. We very good explain our experiments results. We very good correlate such models.
I agree. I agree.
So if we have some questions personally, we can discuss it in class.
Okay.
Kazakistan wanted to ask you a question, Vladimir.
Yeah. If my understanding is correct, you.
Very light flight.
If my understanding is correct, your time, the particle is under the Coulomb barrier. The time is larger the better.
Oh, thank you.
Shorter is better. The time during the particle is staying under the barrier, is it shorter the better?
I don't well understand your question, but I have discussed that we have not.
Yeah, no, okay.
There is no deformation of potential barrier. Barrier is the same. We have create very intensive fluctuation of energy for short time.
If you have a coherent state,
yes,
the the time under the barrier is getting shorter. Is it your comment? Is it your result? Or it is getting larger than the isolated non-coherent state?
Yes, yes. We have calculated the duration of transparency through the barrier. As usually says that such transparency time is equal to 0. No, it isn't correct. It is some necessary time. It is important such time. It's time dependent from the different parameters of size of barriers, of the energy, mass,
Yeah,
particle, so
if
on.
you compare the coherent state and the non-coherent state.
No, coherency is important for creation of fluctuation, for burn of fluctuation. It's very important. So we have the some moment time, we have the such interferency, cophasing coherency, we have the burn of very giant fluctuation. This exists some time. So it is during such period, it is in fact the real energy. In coherent state, such time is very increasing. In the non-coherent state is very small, in coherent, very large. So we have the real, absolutely realistic fluctuation of energy. Particles has a great energy and can, passing through potential barrier, can create it of compound nuclei, can simulated nuclear reaction, but we have such energy, we have you received for short time, only for short time. And if such very long process will be, this
So
process will
you
be
need
very
a short
long,
time
it is
then.
this point. And short time, it is absolutely, it is not a correct value. It is calculated. For coherent correlated state, is short time will be much long, increasing by many, many times, but 10,000 times or more. So we have creation giant fluctuation of energies and can exist for long time. It is two most important properties. In this case, possible stimulated reactor. If we have giant, usual case, giant fluctuation energy that exists very short time, it is a not possible stimulated nuclear reaction. Very simple answer.